So this graph gives you an idea of the number of events that we've been having. And this graph goes back from September last year until yesterday. So as you can see, leading up to this eruption, it was a fairly quiet period. It wasn't very noisy, and it more or less fits with what the eruption is doing. It's been a very quiet eruption so far. But as you notice, there was sort of a ramping up of the number of events in February. So each of these spikes is the number of events on a single day. So the highest total we had on February 20th was just over 200 events on that single day. But as you can see, it's definitely pulsing. But there is some evidence of an increase as time is going on, however. All right, so as I mentioned before, we haven't really had a good look at the dome recently. So the last scan we had was on the 12th of February, which is not really ideal for us. We would like to have a scan every 4 or 5 days if possible. But like I said, it's up to the weather. But these lines, these circles that you see in this photo to the right basically shows you what the dome footprint is, or the outline of the dome at different dates. And as you notice is that the lines in the north-south direction, which is diagonal from top left to bottom right, there's a lot more spacing in between those lines than the lines in the east-west. So it more or less shapes like a peanut, and that's because it has a narrow waist, because it's being squeezed by the crater wall and the old dome. So it's growing faster towards the Larakai area and back towards the rope where you climb down into the crater than it is actually in the east-west direction. But as we can see, it's going at roughly 2 cubic meters per second. And from what we've seen so far, it's been averaging roughly 1 million cubic meters every 8 days. So if I were to guesstimate how much more it would have added in the 2 weeks, I would have used that rate to try and guesstimate, simply because we can't see it. Yeah, that's a brilliant question, and it's definitely a scenario that none of us want to have to deal with. Basically, this is one of the reasons why, or the main reason why, we've got an EDM reflector in place. Because of where the dome is, if it gets big enough, it could start loading that wall, pushing against that wall. Now, if it pushes that wall down, basically what's going to happen is you're going to expose the interior of that dome, the belly of that dome. And that would be a very rapid decompression of that dome. So what you will actually get is a sideways explosion, which we call a lateral blast, a directed blast through that gap of the crater that's missing. So that is something that we definitely hope does not happen. So if it does that, then it's no longer effusive. It's properly explosive then, and a very dangerous explosion at that.
But I have a follow-up to that one that really, so if a lateral blast is going to be more likely, should the people on the leeward side be more prepared than even people on the windward side in that red zone?
Yeah, I don't remember using the word likely. What I said is if the dome decides to push that wall over, then it could generate a lateral blast. At present, we have no data to suggest that it's pushing against that wall, but it's something that we just need to account for. So just let's say hypothetically, if we thought a blast was imminent, because it's a directed hazard, yes, the people of North Leeward would be in more danger, but we are not expecting one at the moment. Let me just be clear about that. We're just saying if the dome pushes that wall down, it could lead to one, but it's not pushing against the wall yet. All right, so I've been speaking a lot about sulfur dioxide in the news recently, and just to clear up what I was saying about the hydrothermal system and the absence of SO2. Now, if you look at this cartoon, to the right of this cartoon is where you have your dormant volcano. And basically you have your water table, this blue area here, where you've got your water. And basically what is happening is reacting with the sulfur dioxide. So at the top of your dormant volcano, when it's not erupting, you will not be seeing any sulfur dioxide. However, as I said, when I got here, the volcano was already erupting, so I should have expected to be seeing sulfur dioxide. However, when I took those measurements, there was none. And the only explanation could have been that there's groundwater still interacting with the sulfur dioxide being produced by your volcano, and I wasn't seeing it. And the evidence for that is that the lake is still present, because the lake is the top of the aquifer. So as long as the lake is still there, I really believe that we're going to still have issues with scrubbing from this volcano, and the SO2 signal will not be pure until the water disappears. But there's still some water there. But I'm seeing some sulfur dioxide. So that tells me that the water is becoming less, but there is still some of it present. So, you know, I also mentioned in the news that when I got here, I had to rethink what I was doing, because the template I use in Montserrat is very different to the one that works here. In Montserrat, I was relying on sulfur dioxide fluxes as the backbone for my monitoring. But as I just mentioned, there is no sulfur dioxide here, so I can't use that. So I had to use another instrument, which is called a multigas, and look at the plume composition to give us an idea of what is happening. So on this graph here, you can see there were some measurements which I took in 2018. In May 2018, when I was here, I took some measurements from the old dome. And then 2 measurements which I've taken with sulfur dioxide so far since I've been here. Both of them are in February. And as you can see, the red star is February 1st, and the blue star is February 18th. And basically what these graphs are telling me that in 2018, the data was plotted in that part of the graph, which is called HD, which means it was dominated by hydrothermal fluids or hydrothermal gases, which was expected. Now you've got your magma degassing because you've got an eruption on. You have 2 options. You can either be degassing from deep or degassing from shallow. Now, the data I've collected so far shows that there's a deep degassing signal, this DMH. But there's also a hydrothermal component still, which matches with the observations that we've made. So the water is still there. So you're still contributing from the hydrothermal system, but you've got a deep magma that's degassing. So over time, when the hydrothermal system disappears, I would expect all of the data that's collected here to plot in that region labeled DM, which is just purely deep magmatic, because the hydrothermal component would have been gone and disappeared when there's no water. So to date, we've got this volcano chugging along at 2 cubic meters per second. Once again, that's a good thing, because you want slow extrusion and not fast extrusion. Compared to Montserrat, as you can see, that's a bit slow. The dome is degassing freely, and based on the textures that we're seeing in the dome rocks that we've collected, we think that is the case. And that is also a good thing, that we're losing gas. Volcanic events are increasing. Well, they have increased slightly. They're not going berserk yet. And we have over 3,000 so far, but you expect more events to happen as your eruption goes on. So that is not outlandish or unusual. The deformation signal has not been too convincing yet, but we have to keep monitoring. The gas compositions, as I said, shows that there's a deep magma, but you still got a hydrothermal system contributing to your emissions. We haven't seen the deep magma yet, but there's more information to come, and we're looking forward to that information. So to date, we haven't seen anything significant in the eruption to make us think that it's changing its mode and it's becoming more violent. And basically, when we have our discussions in terms of what we think is more likely or most likely to happen, these are the 3 options we come up with, and more or less in that order. The most likely thing for it to do in the next 6 months is remain effusive, stop, or go explosive. So based on what we're seeing, we think these are the order in which the likelihoods should occur. However, if the volcano does something different, then we'll have to reassess our views as to what we think is happening. So we have to do that on the fly. Now, I use 6 months for a reason. I think on average, the eruptions here last a bit more than 6 months. So I think 6 months is a reasonable window for forecasting.